Hello, this is Tyler Faulkner with Carlson Software. This video is going to talk about the Calculate Residuals command, show how this can come in handy when you're creating a geologic model. So a bit of background for where this actually comes into play. Once we've collected our drill holes, we've imported them into the program, we want to know how do we interpolate between these data points to show the transitions from one hole to the next. Well, there are 6 methods available in Carlson listed below here. So we have the triangulation method, inverse distance kriging, and so forth. There are pros and cons to each one of these methods, and these methods will give you sometimes drastically different results. This video is not going to specifically talk about the math that goes on in the background for each one of these methods. Instead, we're going to talk about another command we can use to help us pick one or two of these methods to consider. So the question is, which one of these methods do I actually want to use? Well, there is no perfect method. As just mentioned, there are pros and cons to each, and you're best off considering multiple options. You don't want to just blindly pick one of these methods, treat it as a black box, and go with it, because you may not get the best results. So what we recommend doing is to inspect these methods qualitatively and quantitatively. So for example, let's say we have a data set, we select the triangulation method, and then we build our geologic model. From there, we can qualitatively inspect our contours, take a look at some fence diagrams, inspect the volume reports, and just ask ourselves, does this make sense? Am I happy with these results? Now, before we do that, because there are 6 methods, you may be new to each of these, may not have a lot of experience with them, you can use this Calculate Residuals commands, which helps you quantitatively inspect a few different variations of these 6 modeling methods all at once. So just kind of a brief overview. I'll explain the methodology here and then we'll actually show it in the program. Calculate Residuals will help you determine the goodness of fit for a modeling method to a particular data set and even to a particular data value. So you could check this with the thickness of a strata, maybe the elevation or the depth of the strata, and so forth. So the methodology here is to first of all remove one of the data points. Using the remaining data, predict what the value is at that exact same location. You then have a predicted value and a measured value. The difference between these two values is called the residual. If you repeat this for every data point in your set, you can create an average residual value. And this essentially boils down to just one number that helps you determine how well does this modeling method match my data set. So let's drop into the program and show how we actually use this. So here I have a relatively simple set of data, just a few drill holes here. Double click on these. I'm going to show the Calculate Residuals command as if we were inspecting the thickness of this coal bed. So that's the value that I want to model. I'm not as concerned specifically about the bottom elevation or the depth or even any of the attribute values such as heat or sulfur content. I just want to take a look at what is the coal thickness of this seam across the property. So as we explained before, the first step to calculating residuals is to actually throw out one of your data points. I'm actually going to turn off just this middle drill hole here. You notice I do still have the true labels of what the coal thickness is at that point. So I've thrown out one of my data points. Using the remaining holes, I want to predict what is the coal thickness at that location. I've actually already done this here, calculated it for a few modeling methods, a couple variations of them. I've actually got the labels turned on here, so I'll turn that layer on. Let's zoom in a little bit. So the true data value is 3.1 feet coal thickness. However, the triangulation method predicts that using the remaining data points that the coal thickness is 2.97 feet there. So if we take our measured value, 3.1, subtract the predicted value, 2.97, we get a residual value of 0.13. Similarly, if we take a look at the inverse distance method, this method predicted a coal thickness of 2.76 feet. Comparing this to the measured value, we have a residual value of 0.34. we have a residual value for every single one of these modeling methods at that location. So we could take those numbers, stick them off to the side, turn our hole back on, and check this at another data point. So let's turn off this hole. Doing the same thing where we use the remaining data points to predict what the coal thickness is at that location, which I've already done here, stuck in a report. At this location, even though the measured value is 3.5 feet thick, inverse distance method only suggests a thickness of 2.8. Now you may notice that the triangulation, the polynomial methods, didn't actually get a residual value here. We'll talk more about that later. So we have residual value for this location and for this location, and we would stick those numbers off to the side. Let's do this for just one more. Turn that drill hole back on, turn this hole off. Again, using all of these data points, predict what the coal thickness is at that location. So here we can see that the measured value is 2.4. The inverse distance method actually overshot that value this time, suggesting 2.74. Linear least squares, however, undershot that value, 1.89. So you can see, just in this one location, these modeling methods will give you very different results. Well, if we took a residual value for every single one of these drill holes, we would get an absolute value, a residual average. So this is, again, just one number that tells you how well does this modeling method match my drill holes. I'm going to show you how we could actually do this, not trying to do all this by hand, because if we have a more complicated set of data, it's going to be very time consuming to try to do all this by hand. So I am in the Geology module. We're going to do this from scratch. Under the StrataCalc pull-down menu, you can see I have two options here, calculate residuals and auto run residuals. The first command will calculate the residual for just one modeling method. And since we want to compare multiples at once, it's better to use the auto run, because then you can compare triangulation to inverse distance to Kriging and so forth. So let's build this up. Activate the command. I'm told to select the drill holes, channel samples, and strata polylines. If I grab all my drill holes, you can see I found 39 of them. Press enter. And this is actually remembered my results from the last time. I'm going to clear this out, and we're going to build this up from scratch. So I'm going to add a new residual to calculate. First of all, I'm going to choose the strata to process. I'm going to find my MM key, and I'm going to take a look at the thickness of that strata. With that set, I can select the modeling method I want to test. I'm going to start out with the triangulation method. I'm going to accept the defaults, say OK. So that adds a new row to check here. I'm then going to add another one. Choose strata to process, MM key, thickness. For this one, I want to look at the inverse distance method. I'm going to select the inverse distance power of 2 for this case, search radius of 10,000, so forth. Set my parameters the way I want them. Say OK. I'll add one more. Choose strata to process, MM key, thickness, inverse distance. This time I'm going to make a small variation where I'm going to use inverse distance power of 3 in this case. Is that okay? And I can add this for as many variations of these methods as I want. I've actually already got one built up, so I'm going to go ahead and load, which it's the exact same process to add other modeling methods. So here I've got a few variations. I've actually got 11 variations of modeling methods. So I've got 3 Krigings, 2 ABOS methods, 2 least squares, and so forth. I want to compare all these methods together, get an idea of how well do these methods match my data set. Once I have that, I can save this out if I want to come back to it later. But I'm just going to go ahead and calculate my residuals. Program thinks for just a minute. And we're now at the report formatter. So it's calculated the residuals. How do I actually want to present this information? You can see I've got a little bit of information already over here on the use column. The main numbers I like to look at, just the strata that we're looking at, the value that we were modeling, and the modeling method. I also want to take a look at the number of samples that were actually used and this absolute value residual average. Take a look at those. Got just those 5 fields. I can use these if I want. I'm just going to display this report. And you can see we have each one of our modeling methods listed out. All of these relate to this key strata. All of these were modeling the thickness. So you can see for the triangulation method, we were only able to use 28 samples, whereas with some of these other methods, we were able to use a full 39. That's just kind of locked up in the way that that modeling method works. It can only interpolate. It can't extrapolate well. Carlson does have methods to actually extrapolate with the triangulation and the polynomial method, but just for calculating residuals, it doesn't do that. So one thing to consider here, if you find that one of your modeling methods only uses just a small handful of samples, whereas the other ones use a larger number of samples, you may want to give some more credit to the ones that used a larger number of samples. The main value I'm trying to get at here is this absolute value residual average, and this is just the one number that tells you how well this modeling method is matching your data set. So on average, the modeling method will get within 0.31 feet of the true measured value when using the triangulation method. If we scroll down on the list here, you can see we've got a couple of lower values here. Both of these using the ABOS, stands for approximation based on smoothing. That gave us a little bit tighter. Now you'll notice 0.28 is not that much different from a 0.31. However, if we look down here a bit further, using my third Kriging method, which I believe I used a Gaussian model in that case, we got a higher residual value. So these numbers are pretty close to the actual data values. That's actually good news. That means I wouldn't expect to have terrible results with any one of these modeling methods. But this doesn't absolutely tell me which one is best. But it does tell me I absolutely want to consider the ABOS method. I absolutely want to consider inverse distance, and I absolutely want to consider triangulation polynomial. I probably don't want to try a Gaussian just because I don't expect as tight results. So I've taken a look at that. I can pick one of my modeling methods. I can create contours, I can create fence diagrams, take a look at the reserve estimations, see which one of those few methods am I actually going to use. So one other thing I want to point out is that the residual value we just calculated, that gave us an idea of which modeling method to use when creating these thickness contours. However, if I'm modeling a different attribute, such as the heat content of the coal, the sulfur, or maybe just even the elevation, I may want to select a different modeling method. I'm going to rerun auto run residuals, select my drill holes, and I'm going to clear out what's there. I'm going to load up another one of these files I've already created. Exact same process, just clicking a different option. For this auto run file, I've set this up for the elevation. If I calculate the residuals here, again, the program takes just a moment to think here. And we're back at the report formatter. I'm going to inspect the number of samples and this absolute value residual average. If I display these results, you'll notice still the same number of samples used for each one of these modeling methods. The absolute value residual average, much higher. These elevation ranges are in range of 300, whereas the thicknesses, those are only values of 3 or 4, so you can expect some larger numbers here. But we do have some interesting results. Whereas we were modeling the thickness, the ABOS method came out to be very strong, had a very low residual average. In this case, however, when modeling the elevations, ABOS actually looks to be the worst method. So that's just kind of an indicator of, picking just one value to model may not be enough. You can't just say this worked for the thickness, so it must work well for the heating content and the sulfur as well. You need to check this for a few different runs. So in this case, what these results are telling me, my 2 Kriging runs here, I know that that's spherical on the top, exponential model in the middle. I found that those are my lowest values. So when modeling the elevations, I absolutely want to consider those methods. I probably don't want to even look at the ABOS elevation model because I don't expect to get good results. But this will just help guide you. Say, it's not going to tell you exactly which method to use, but it does help guide you and give you some quantitative data to back up the decision that you've made. Now, just to expand on this a little bit further, I selected a few modeling methods to contour the bottom elevation for that strata for. I have them shown here. So just selected 8 of them. And you can see we get some drastically different results in just the way the contours appear. The triangulation method for this data set, very jagged, has very sharp transitions, almost constant gradient slopes between these data points. And that's expected just the way the math actually works in the background. The ABOS and the Kriging method, however, give me much, much smoother transitions. So again, there's a lot of things to consider here. Which one actually looks sensible? Which one am I going to be happy with? Which one can I base economic decisions on? Now, just to expand on this a little bit better, I've seen data sets where the Kriging method gave me about 85 million cubic yards of material. Triangulation method only gave me 60 million cubic yards of material. Those are very serious numbers. That could absolutely make or break the decision of, do I line this or do I not? So that's just kind of the importance of knowing which one of these modeling methods you want to use, being able to trust the results that it gives you, and use your best engineering judgment in this case. Thank you for your time. If you have any questions, you can call us at 606-564-5028, or you can email in to support@carlsonsw.com. Thanks.